graders, welcome to your fourth lesson. In this lesson we're going to be talking about the power of monomials. Our objective is to find what a power of a power is, and we also need to find the power of a product. Product is the answer of multiplication. Power of a power means that we're going to take a power and we're going to make it go to another power. The standards that we're going to be addressing is 8th grade standard equivalent expression standard number 1. Let's get started on our vocab and let's get going with this lesson. In this lesson, we're really going to talk about the key concept of the power of a power. What that means is to find the power of a power, all we got to do is multiply the exponents. So in this lesson, we're going to be multiplying the exponents. Do not get it confused when multiplying numbers that have the same base that you add the powers. In this case, we're actually multiplying the exponents. And you'll see that these are kind of a little bit different. The reason why we're able to multiply these exponents is because if you look here, it says we have 5 to the second power 3 times. So we take 2 times 3 to get 5 to the 6th power. This little 3 right here means that we're really seeing it 3 times. So I'm going to write that out. 5 to the second times 5 to the second times 5 to the second. So we know that an exponent means how many times we see a number. Well, we now see 5 squared 3 times. Now this does apply to the rule that we had previously. 5 to the second times 5 to the second times 5 to the second. Since all of those numbers are multiplying and they all have the same base, we can add those exponents. 2 plus 2 plus 2, 5 to the 6th power. So instead of writing something out 3, 4, 5, 6, 7, 8, 9, 10 times, what we decided to do was if you have some number that has a power and it's going to another power, which means it's a power of a power, all you got to do is multiply the exponents to figure out what the total is going to be. Where in this case, we have a number showing up 3 times, and since it's the same base, we can add the exponents and we'll still get the same answer. So instead of expanding it out, we are able to get the same answer just by multiplying the 2 exponents, because one's on the inside, one's on the outside. The way it works in algebra is kind of the same deal. A variable to the power of m, and the whole thing is going to the power of n, which means we see it n times. Well, all we got to do is take m times n, and that will give us our total of a to the power of m times n. So let's practice this. Let's see if you guys can get it, and let's get going. In our first example, we have to simplify using the laws of exponents, so we have to figure out what law we're using. In this problem, it says 8 to the 4th power, that entire thing going to the 3rd power. Again, notice that the 8 to the 4th power is inside parentheses. So we could say that since this is inside parentheses and the whole thing's going to the 3rd power, we could say that we could write it 3 times. 8 to the 4th times 8 to the 4th times 8 to the 4th. You don't have to write it 3 times, but you can write it 3 times. Well, now that we did that, we can actually use the rule that we learned in the previous lessons that says that as long as numbers are multiplying and they have the same base, so they're all 8s, we can add the exponents since they're all multiplying. So 4 plus 4, that's 8. 8 plus 4, that's 12. So this is really 8 to the power of 12. But instead of doing that, and writing it all out, because we're not going to always write it out. Instead of doing that, what we can do is we can say, okay, we have this coming up 3 times, and we have 4 as our exponent. So all we have to do is say that this is really 8 to the power of 4 times 3. And 4 times 3 is 12. We'll get the same answer if we do it this way. We're able to multiply these powers because we're doing a power of a power rule. Let's practice a few more. This time, let's not expand it out. Let's just see if we can get the right answer. Alright, so we're just going to not write this out 8 times because that's what the 8 would mean. What we're going to do is we're going to apply the power of a power rule. We have a number that has a power, and it's going to another power. So since we have that, all we've got to do is say that this is really 5 to the 2nd power times 8. Well, 5 to the 2nd power times 8 is 5 to the power of 16. And that's really it for this type of example that we're doing here. It's that easy. So just make sure that you know that if you take a power and you make it go to another power, that you really just multiply the powers. So here we have k to the 7th power, and it's going to the 5th power. We could expand it out and write k to the 7th power 5 times, but instead of doing that, we're just going to apply the power of a power rule. We have a variable to a power, and it's going to another power. So that means that we can take k to the power of 7 times 5, which really equals k to the power of 35. Let's try another example. This time, see if you can do it on your own. Go ahead and pause the video on the next slide and see if you got it. In example 4, we got a to the power of 3 going to the power of 7. If you feel like you got it, go ahead and write down the answer. I'm going to go ahead and solve this. This is a to the power of 3 times 7, and 3 times 7 is 21. So, this is a to the power of 21. That's how easy some of these problems are. So just make sure you know that the power of power rule says if you have a number that has an exponent going to another power, all you do is multiply the two powers, power of a power. Here's where things change a little bit. Make sure you're definitely paying attention. Copy down this problem. Don't do anything until I'm done solving the problem, so that way you can actually get how to solve this type of problem. What we have here is we have 4p to the third power. The entire problem here is happening 4 times. So if I were to expand this out, this is the way it would look. It'd be 4p to the third power times 4p to the third power times 4p to the third power times 4p to the third power. Again, I wrote it 4 times, and we don't want to have to expand everything out that many times to get to this answer. And there is an easier way. What we could do is we could look at the numbers, and we could write it exponentially. We look at the numbers, we have 1, 2, 3, 4. So this is actually equal to 4 to the fourth power. And then we look at the p's. Well, p to the third times p to the third times p to the third times p to the third. Since they all have the same base, we would add their exponents. 3 plus 3, that's 6. 6 plus 3, that's 9. 9 plus 3, that's 12. So this problem really should be 4 to the fourth power, p to the 12th power. And we can still apply the power of a power rule, but instead this is actually the product of power rules, because we're going to get the answer of multiplication when taking something to a power. So what we're going to do is this 4 doesn't just go to the 3 and multiply, but this 4 actually goes to this 4 and multiplies. Now, you might not see it, but this 4, we actually have one of those. So what we do is we still multiply the powers. It's 4 to the first power, and we take 1 times 4, and we get 4 to the fourth power. This is p to the third power, and we take 3, and we times it by 4, and we get p to the 12th power. Now, this would be correct. The only thing is, PEMDAS says that if you have a number that has an exponent, like 4 to the fourth power, you might want to actually figure that out. So in this case, I'm going to go ahead and use the calculator. I'm going to type it in. I've got my calculator right here. 4 times 4 times 4 times 4, I get 256. So this answer is equal to 256 p to the 12th power. Again, you don't want to have a number that has an exponent. If you can solve it, go ahead and solve it. I figured out that 4 to the fourth power is 256, and I know that this is multiplying by that, so it's 256 times p to the 12th. So these types of problems, the exponent goes to not just the letter, but the exponent goes to both numbers on the inside. And if your number doesn't have an exponent, you can always put an exponent of 1 in there and then multiply. You could have got the same answer by doing this, and you would have got that this is 4 times 4 times 4 times 4, which is 256, and p to the third times 4 times, you got p to the 12th. You get the same answer doing it expanded out, but this is the way that I want you to get used to doing it, using the power of a power rule. The power on the outside multiplies to each power on the inside. So let's practice another one without going over all this detail that we just did. In example 6, we're going to just apply the power of a power rule. Remember that if we have a number by itself, one of the first things we can do is we can write down that it's to the power of 1. Now, what we're going to do is we're going to apply the power of a power rule. That means the power that's on the outside is going to multiply to the powers on the inside. So this is really 3 times 1 and 3 times 5. Well, 3 times 1 is 3, so this is 3 to the third power. And 3 times 5, that's 15, so this is 15, or c to the 15th power. Now, as we stated in the previous example, if we have a number that has an exponent and we can figure that out, we need to go ahead and figure this out. So 3 to the third power really is 3 times 3 times 3. And so if you need to have a calculator, you can go ahead and have a calculator. 3 times 3 is 9. 9 times 3, 27. So this answer is 27c to the 15th power. Now notice that I don't have a number that has an exponent, but I do have a variable that has an exponent. And that's our answer for this problem. We got 2 more problems, and then you guys are done. That easy. Example 7. If you feel like you got it, go ahead and try this problem. Go ahead and pause it. Again, the best way to do this is to pause the video, see if you can do it, and then play the video and see if you got it right. Don't do anything until the end. Pause it and copy everything down. So I'm going to go ahead and solve this. Go ahead and solve it. Cool. So I have a number that doesn't have an exponent. I'm going to go ahead and put a 1 there. This 5 doesn't just go to the 6, but this 5 goes to the 7, and it goes to the 1. So I got to multiply that 5 to all those exponents. So what I really have is a negative 2 to the 5th power, an m, 5 times 7, to the 35th power, and an n, 5 times 6, to the 30th power. So this would kind of be my answer. And if you got this, I'll probably give you a B on your test. But again, if you have a number that has an exponent, you want to actually figure that out. So this is really a negative 2 times negative 2 times negative 2 times negative 2 times negative 2. Well, if I look at this, I have negative times negative, that's a positive, times negative, that's a negative, negative and negative, make a positive, and positive and negative, make a negative. So this is a negative number. 2 times 2, that's 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. So my answer is going to be a negative 32 in these variables. So the final answer is negative 32, m to the power 35, n to the power 30. And all we did was simplify using exponents. This looks a lot nicer and easier to work with than that. And notice that there's no exponents outside the parentheses. Last problem, let's go ahead and do that, and then you guys are done for a day. Quick, easy lesson. Make sure you're ready, make sure you have your notes, and we'll get going. For our final example, example number 8, I'd like you to go ahead and pause the video. Honestly, I really would love it if you could do this problem on your own. If you can't, that's okay. I'm still going to go through it, and we're still going to practice in class. You'll be absolutely fine. So here we have negative 4 p to the 5th power q, that entire problem going to the 2nd power. I'm going to start by doing what we did earlier, and every number that's by itself, I'm going to put the exponent of 1. So this is a negative 4 to the 1st power, and this is a q to the 1st power. Now we're going to apply the power rule, and we're going to take the power on the outside and multiply it to every power on the inside. So this is negative 4, 1 times 2 to the 2nd power. This is p, 2 times 5 to the 10th power, and q, 1 times 2 to the 2nd power. Again, we have a number that has a power that we want to get rid of. So we're going to go ahead and get rid of that. A negative 4 times negative 4, that's a positive 16. So this answer is 16 p to the 10th power, q to the 2nd power. If you have any questions, make sure you have them written down. You need to at least have one, and I'll see you in class tomorrow. If you haven't yet, go ahead and like this video, subscribe, hit that notification bell, and let's get doing some math.